In this chapter, we're not going to be using too many formulas, but it's helpful to keep that in mind that we need to use the decimal form rather than the percentage form in a formula. But what I wanted to talk about next is how to solve basic percentage problems and a few tricks and tips for you guys. So there's ways of calculating percentages in your head that and a few methods to that I wanted to share with you guys, including an alternative way of thinking about. Say for example, you wanted to figure out 15% off. What's another way we could calculate that a more direct way into those formulas, and just some general properties to as we continue. But one basic idea with percentage that can often be misleading, and you can ignore the meme over there. Let me get rid of that because that's highly distracting. But one thing I wanted to mention about percentages is that's not helping me focus on lecture. Is that percentages are always multiplicative as opposed to additive. So, like, say I was talking about 20% of something, that percentage is always multiplied into the original quantity in order to calculate the value that we need to know. So, say for example, I have $100 and I want to know what 20% is. Well, that's easy because it's 20 out of 100, and if I have $100, it's very easy to figure out. But say I had $122 and I wanted to know 20%, that's kind of the value of a percentage, is it can be multiplied into the number, and when you multiply it into it, it gives you exactly the desired percentage. And if we change it to its decimal form, that is exactly perfect. So I would just take zero point 0.2 times whatever, and that would give us the effect. But the reason why I say it's misleading is that if percentages are applied to another percentage, there's some things that wouldn't necessarily agree with maybe common sense, or could defy what a lot of people would think would happen. Like, let's look at this example. At work, let's say your salary starts at $60,000. Um, 1 year, you get a 5% raise because you're a good employer or whatever. Then later, another year, you get another 5% raise. And the question is, well, what's your new salary? And does that amount to a 10% raise? Because, right, if this is my salary, it goes up by 5% and then up by 5% again, so some people would think that, okay, that should be 10%. But the thing about percentages is they don't work that way. If you apply a percentage to another percent, one of the ways we phrase it is they compound, because when we're multiplying by 0.05, if you multiply by 0.05 twice, that doesn't amount to 0.10 of that number. So let's throw some numbers into this to kind of make sense of why that works that way. So let's say we're going to start with a salary of $1,600 or $60,000. If we apply our first raise to that, that would amount to be, well, and this brings up another point about how to apply a percentage that I wanted to mention. Like, if I think about what does a 5% raise mean, well, that means I want to take 5% of my initial salary, which is multiplied by 0.05, which would be $3,000. And I can take that $3,000 and add it to my initial salary. And that would give me my new salary after the 5% raise. And so the reason I walk through those steps is actually there's a shortcut to calculating a 5% raise. And this is kind of an alternative way of thinking about percentages, which is what I was another trick that I wanted to mention. And technically, you don't, if this is too confusing, you don't have to think about it this way, but this is just how I think about percentages. And I always teach my students this because I think it makes a lot of sense personally. But if I think about, my initial salary, I could think about my initial salary as the whole amount. I'm getting this much money per year. And if I add another percentage on top of that, let's just say in this case that's 5%. I could think about the new quantity as my desired outcome, which what's important to remember is the initial salary is going to be always considered to be the whole, or 100%. Because 100% is equal to 1, it's always the amount that we start with. And if I lop on 5% on top of what I started with, what that amounts to is a total of 105%. So instead of, and my point here is, instead of taking my initial salary and multiplying by 5%, I could take my initial salary and multiply by 105%, which would be 1.05, And that would give me the direct calculation. Instead of having to do, notice, I did two steps here where I took 5%, which was 3,000, and I added it to the initial. But really, this is like 100% plus 5%, which amounts to 105%. So I can kind of do that whole calculation in one step. And this is like a mental strategy for figuring out, like, what's a 5% raise mean? Multiplying by 1.05. But the other point that I wanted to get back to is, well, why is that not 10% if I get another 5% raise on top of that? Why is that not 10%? But basically, how I could think about this is after 1 year, or after my first raise, my new salary is $6,300. And now if I get another 5% raise on top of that, that raise will be applied to my new salary, right? Because the percentages are always with reference to what your current position is, right? And so the 5% on the new salary is going to be a different raise than the previous raise because my salary has now changed. So if I take that new salary and now I get another 5% raise, and again, to shortcut this, I'm going to, instead of multiplying by 0.05, I'm going to multiply by 1.05 because that will include the initial salary plus interest. Or not plus interest, I mean plus the raise. And this should give me my salary after after the second raise. And notice that secondary raise, if I was to just have done only by 0.05, would be $3,150. So I can see that my second raise was actually a little bit more, and it doesn't amount to a 10% raise, because a 10% raise on the initial salary of $60,000 would have been $66,000. But notice that if I have two raises of 5%, it's a little bit more than a single 10% raise. And how I could actually calculate, well, what is two 5% raises by multiplying those two percentages together. And notice that that if I apply two separate 5% raises in succession, what that amounts to is actually a 10.25% raise. So this is kind of what I mean by it's not additive, it's multiplicative. If I take two 5% raises, it's not 10%, it's actually 10.25%, and coming up with that calculation is a little bit tricky because you can't just add them together to get the right result. But all that being said, I just lost my train of thought. But these are some tips. I don't know if hopefully I'm not making this too confusing, but we can kind of see what the net effect of that raise is by the multiplier. Oh, and this is the point I wanted to make, is that this is the idea of what compounding means. And when we refer to compound interest next week in some of the formulas, it works a little different than basic percentages, because let's say that I have a savings account or a loan, and every month there's a certain interest rate that's applied to it. But as an interest rate is just a percentage which will multiply into our account, just like this example. So I could think of taking the growth of my account as the interest as a multiply, say, by 1.05. And if that's going to happen every month or whatever, well, that would be extreme for 1 month. But just, for the sake of this argument, every time I apply that interest rate, it's going to be multiplied and multiplied and multiplied. And the effect of compounding is that over time it will get the growth will get more and more and more. As we saw from these examples, the first increment of 5% growth was $3,000. The second increment of 5% growth there was $3,150. It got a little bit more because interest is always based on the current value of my salary, right? And as the percentage is applied, my salary goes up. So the growth goes up over time. And that's the idea of compounding. As we multiply and multiply and multiply, it compounds. Anyways, that's kind of what that word means in a mathematical sense as well. And in the next video, I wanted to get into some of the examples from the packet and do some more percent problems. But one last formula that I wanted to discuss, just because we might use this from time to time, which is a general mathematical formula, is sometimes a question might ask you to figure out what percent, say for example, a new dress costs $80 and is now on sale for $50. And you want to know, well, what's the percent change in that, or like how many percent off is this dress? What's been the price reduction percentage. But there's a general formula for percentage that you can always apply to pretty much any percentage situation where you have a change in price. And basically, you just want to take, well, what's the difference in the original price minus the new price? It's kind of like, well, how much has it changed? And that should always be divided by what it started with. And sometimes the context could be, well, you might want to divide by the new price, and it really just depends on the quantity of the percentage you're focused on. But this formula is the general structure is, well, how much has the price changed in the item, and take that as a ratio to the starting item. And this percentage we'll talk about this more when we do some examples in the packet, but I just thought I'd mention the formula before we get started.